All right, this is a lesson on the number of ways to rearrange the letters in a word. I've already done this in a previous video, but we're going to do it again in a little more detail, a little more complicated. All right, so let's start off with a word like Ben. So B-E-N, how many different ways can you rearrange the letters B-E-N? So I've already written this all out, and I've got right here, there's 6 ways. So these are the 6 ways to rearrange the letters in the word Ben, or the name Ben. All right, and how do you figure that out without writing them all out? You just do 3 times 2 times 1, which is 6. Right? 3 because there's 3 letters that can go first. But once you pick a letter to go first, then there's only 2 that can go second, and then there's only 1 left over to go last. Another way to do that same problem is 3 factorial, which is 6. Or we can use the definition I gave you in a previous video of a permutation. So we've got 3p3. This 3 is because there's 3 letters, and this 3 is because you want to rearrange all 3 letters, right? So this is the total letters you've got, and these are the number of those letters you want to rearrange. Now, the way you write that out formulaic, the formula anyway, is you put 3 factorial on the top. That's that first 3, right? So that goes here. And you divide by the difference between these two. So 3 minus 3 factorial. Now 3 minus 3 factorial is 0 factorial. So now you have 3 factorial over 0 factorial. But 0 factorial is 1. I know that doesn't seem to make sense, but it is. So 3 factorial is 6. 0 factorial is 1. 6 divided by 1 is 6. Okay, I don't require that you use this, but you know, if you have a calculator, you could just put in 3p3 and it would give you 6. Or you could put in 3 factorial, same thing. Or just do 3 times 2 times 1. All right, so let's talk about if you have repeated letters. So here's the word been. I've been for a walk. I've been out for a walk. So we've got 1, 2, 3, 4 letters. So how many ways are there to rearrange these 4 words? I'm sorry, these 4 letters. Well, I used colors to differentiate between the 2 E's, right? So this one's blue, this one's red. So all I did here is I just switched those 2. Instead of blue, red, I've got red, blue. Okay, here's another way I could rearrange them, B-E-N-E. And then I just switched the 2 colors. Red, blue, blue, red. Okay, here's another way I could rearrange these 4 letters. B-N-E-E. And down here I did the same thing and switched the colors. Okay, and I could keep going. There are more ways, right? There's N-E-E-B I could do, for instance, right? And then this would have to be, let's make that one red, and let's make this one blue. Well, then I could switch those. Like so. Right? So now we've got 8. All right, there's a lot of these, so I don't really care to write them all out. So how many ways are there to rearrange the letters? Well, there's 24. Since there's 4 letters, it's 4 times 3 times 2 times 1, which is 24. However, most of the time when you're asked this type of problem, they're interested in distinguishable ways, right? So how many unique or distinguishable ways are there to rearrange the letters? So there aren't as many because, as you can see right here, these 2 would be indistinguishable if I didn't use the colors, right? If I just use B-E-E-N, and then this one would also be B-E-E-N, you can't tell the difference between these two. So you count them as one thing, right? So there are 24 if you distinguish between the E's, but there's only half as many if you don't distinguish between the E's. In other words, if you can't tell them apart. So since there's 2 E's, we have to divide by 2 factorial, right? 2 factorial is just 2 times 1 right here. Right? So it's really 24, it's half of 24, which is 12. So there will be 12 of these. You can see I've got 4 so far. 1, 2, 3, 4. There's 8 more I could write out. Any questions on that? I don't know why I'm asking you if you have any questions, because I can't answer them. I have it. All right. So let's look at banana. Okay. In banana, you have a lot of repeating letters, right? You've got 1, 2, 3, 4, 5, 6 letters. However, you've got 3 A's and you got 2 N's. Now let's just talk about the A's. For this one arrangement, the proper arrangement in the word banana, I can rearrange those A's 6 different ways, right? So I've got a red A, an orange A, and a blue A. Or an orange A, then red, then blue. Or I could do red, then blue, then orange. Or orange, blue, and red. Blue, orange, and red. Blue, red, and orange, right? So right there, just for that one arrangement of banana, there's 6 indistinguishable orders due only to the A's. So it's kind of complicated. So how many ways are there, distinguishable ways to rearrange this? Well, there's 6 factorial ways to arrange these letters, right? Because there's 6 letters. That's 120 ways. However, you've got 3 A's. So you have to divide by 3 factorial because of the A's. And you've got 2 N's. So you have to divide again by 2 factorial because of the N's, right? So because of the A's, you divide by 3 factorial. Because of the N's, you divide by 2 factorial. So 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. Right here, that's because of the A's, right? And this is because of the N's. So this 3 times 2 times 1 cancels out with that 3 times 2 times 1. Those are gone. So you end up with 6 times 5, which is 30, times 4, which is 120, over 2 times 1, which is 2, so 60. So there are 60 distinguishable ways, right? Or unique ways to rearrange those letters. All right, and I'm going to leave this one for you. So let's talk about Mississippi. You've got 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. However, you've got 4 S's. So that's why I divided by 4 factorial. You've got 4 I's. So I divided by 4 factorial again. And you got 2 P's. So I divided by 2 factorial again. And I'm going to leave that one for you to do on your own, and on the Edpuzzle video, maybe a couple extra problems for you to practice with. All right, thanks for watching.